upside down? Yes, it is. All right, are there any questions on the test? Go ahead.
It's actually right.
Oh, is that true? Oh, good for you. Oh, yeah. That was one of those, you had to do one that had fractions. Otherwise, what's the point? You could do them all by graphs if otherwise. Anyways, but besides, are the questions, problems that you want me to do to show you how to do them? Remember, you get a second shot at all these things, so this isn't the end of the world.
It's two, actually.
Okay. Let me go and start this up. I'm going to delete some of these. I don't need these around. I believe all of these have been posted at one time or another.
Also, is there like there's a form test or it's just the final?
I'll have to look at the syllabus, but there usually is a port test.
Okay.
Delete this. Okay, I got like that. Today is the 20th, all right. So this was tested. Problem number 2.
It's one of my classes. Those two. I'm just making sure I'm not on because like. Something this is.
I don't know if like those things help me get through a class. I don't know what I would be like to do. Yeah. Just these in here. We have negative x plus 8y 16. The other one was negative x plus 2y negative 2. You want to graph both of those things and see where they intersect each other. And so for both of these, they're not in the desired format at all. What do you got to do with them? Y equals. Let's convert these. You have to do that first. Format that is not going to work. So let's start with the first one. Tell me how you would go and convert that to y equals. Basically, it's solving for y is all this is. You can't go ahead and figure it out. So I add x to both sides and I'll get this. Now what will I do? By 8. So you get y equals 1/8 x plus 2. Let me pause there. You know, I do that pretty fast. I don't know that everybody follows how I'm able to go from this step to that step. So you can tell.
You go from 16 2 times.
But what about the 1/8 x?
Something over.
Let me break it down because the trying to mimic or memorize the steps without understanding them is that goes. So you do have this when you have fractions. I'm permitted to take them and put them together if I want to, but I'm also permitted to break them apart. That little step that I did there is necessary most of the time to get the equation that you want. So now let me step back another step. So 16 over 8, you're correct, is 2. But are you comfortable with x over 8 being the same as 1/8 x?
Plus 2.
That's right. What I'm saying is x over 8 the same as 1/8 times x. So I'm asking you this right now. I have, you can see where the 2 came from at 16 over 8. And you see where the x over 8 turned into 1/8 x. Tell me why that is. No, x is not there. No value. In fact, x is not any value. So this stuff, you haven't been able to tell me what it is that allows me to say this is the same as this, and that's crucial to the whole thing. If I gave you this, do you understand you multiply the numerators together and the denominators together, correct? Okay. Now, instead of writing x over 1, I'm going to sort it as x. Is that okay? So I just need you to understand that if that has been something that caused you issues all this time, I didn't know about it. All right, so we have that. Then why don't, since the other one is identical in nature to what I just did, try to get the second one back. The second equation, try to get it into the y, the slope intercept form. Khalil, turn off your microphone.
Sorry about that.
Just put the result for the second one. Did you guys get that? 1/2 x minus 1. But so I'm guessing not. so the first step, you had this, right? 2y equals x minus 2. That's both sides. Divide by 2. That way y is alone, and you need to break the fraction up. And then, of course, that converts to 1/2. You need to bring the number up front, because then you won't tell what the slope is if you don't do that. Number needs to be in front of x for you to see it. So do you understand the 1/2 times x then? Good with that? It's only now these are the things we're going to grab. This one. So all that was required before you even got to do the problem. Those are the things I'm going to grab. Let me get myself a graph ready. Where is it at? Draw. There it is. Let's start with the first one, the 1/8 x plus 2. Remember the way this works is I am going to place a dot somewhere on this graph. So I'm doing the 1/2, no wait, what is it? 1/8 x plus 2. Tell me where I put my first dot. 1, 2, and I put a dot. But I get it. It's hard for me. Got it. That sounded terrible. Was that up there or out there? Who's eating chips on? All right. Do they bring virtual ones for everybody? Anyways, now that we have this, I've got the point. How do I draw another point? Up 1, and then what? 3, 4, 5, 6, 7, 8. You can do as many as you need or want. You probably ran off the page at this point. So if I need to do another point just for my own comfort level, what do I do from here? No, I've already ran out of page.
Do we go down,
Yeah, and then what?
left?
That's right. We did. Oh, I see. I get it. Oh, all right. Let's get this from here. Here. I'm going to stretch it. It's supposed to go far in both directions. I noticed on the graphs that I saw people, when they get to the point of intersection, they just stopped. That was enough of their graph, but that's technically not how. Come on, stop chirping around. All right, I got that one. Okay, next one. Then the other one, what was that one? 1/2 x minus 1. Tell me how to start that one. Here's the ball. What'd you say? I'm starting here at the origin. Tell me how to go.
-1,
Which way is that?
down.
Come on, let's go. Harder to get it on that spot than you think. All right, now that I got that, what do I do from here? One-half x minus 1. I've got
Up 1 over 2.
up
I
one.
mean, up 1 to the right 2.
Correct, exactly. And you probably see on these graph ones, you know when you're going to be done, don't you? Because can you tell what the answer is going to be right now? It'll be 8, 3. Technically speaking, I don't need any more line than that. I already know where they intersect, so that's good enough for me. Holy cow, I can't believe how hard this is to do. So this guy right here, this is our answer. Any questions about that? Yeah. We do whatever you want.
Professor, can we do number 2 after that?
Did I do number 2? That is number 2 that I did.
Oh, okay, never mind. I thought so. Okay, I got mixed up.
Other questions?
Number 3.
Oh, that was the substitution. Okay. Well, I'll just write them up. We'll just review it. See, when you guys ask questions, I have this weird thing. So it excites me. So, substitution was what was required of you here. You see how x is easily solved for right here? What are you going to do with that x? Just take it and put it into that spot right there. So when you write your 3x plus 5y equals 5, I'm going to replace the x. So this x replaced 3y minus 17. So I'll try to solve for a while. I don't invent it. When I saw it, I'm like, oh, interesting. I don't know what to do because it kind of looks like you're supposed to elimination the way it's set up. But the x is not in the right spot. So it was upon you to turn and say, no, that's not exactly the format. Yeah, that's the thing about math is everything, all those little details are. All right, so this will allow me to get y. So I will have 9y minus 51 plus 5y equals 5. You know how I got those numbers? Distributed, that's right. Now what am I going to do next? That's right. Minus 51. That's technically that signs right, but that's okay. Do that too. I would say you move it to the side or move it to that side so you get used to that. But technically, that's technically not what you're doing. All right, what are we doing now? 5 by 14, y is equal to 4. That's right, so that was the easy one, so I got my 4. What goes in that spot? But you already have that 3y minus 17 equals x. So if I replace y with 4, what does x equal? -5. Right, -5. All right, other questions? Substitution. X. It is substitution. All I gotta do is take this number, this thing here. Spot. Well, 3x, I didn't even have to solve for x. I had solved for 3x and it was already done.
So are you replacing the x with 3x?
No. There's 3x here, right? Yes. I'm replacing 3x with 3x.
So you're just gonna write 4y minus 19.
In that spot, right? It's exactly right. So that becomes 4y minus 19. So there, you see the 3x there? 4y minus 19? That's 3x. 4y's cancel. What was it, 9 or 19? All right, so we end up with the 4y still cancel out. You end up with -9 equals. You can might as well stop there. What does this tell you? Does -9 equal 18? First of all, no, this is a completely false statement. So when you get to these, what are you supposed to say about the problem itself? No, that's right, no solution. The problem was so bad that it doesn't even matter what x you put in, you'll always end up with this stupid statement no matter what. If you added 9 to both sides, which you might have done, you probably would have ended up with an equation like 0 equals 27, which is still wrong. So it's still completely false. Good question. I'll put these up, these solutions that I have, but that doesn't always help when you need a verbal explanation.
Yeah, we do 6b.
6b.
Yes, I keep doing this problem well.
Well, you knew they were coming, right? The test is identical. Now this one, if you look, this was a homework problem. I got it from them. So I don't, because the way it's described is it's unusual, let's put it that way. This was 6b. It's the one A down also. All right. salad dressing in my notes. I use the letter S, but it's Italian dressing. Okay, the Italian dressing here is 8% vinegar. It's 100% with 8% to get something in between. So we need to give names to these things. What letters do you want to call these things? X and Y, I don't care. So what you want to do, X for which one? So X is going to be the vinegar. And Y will then be the Italian dressing. Well, he wants to get a 31% vinegar solution. And he wants a total of how much does he want? 60 milliliters. All right, so let's start first of all. Can you tell me what this equals? 60. X and Y are the amounts you're using, aren't they? So the total amount is X plus Y. It's the other question that's difficult. Here you're mixing 100% vinegar. What is 100% equal to? It's equal to 1. What is 8% equal to?
0.
And then the result was 0.31 times that quantity, right? Concentration times quantity, everyone. Concentration times quantity. Concentration times quantity. Concentration times quantity. That second equation is actually telling you how much vinegar is in the whole thing. The amount of X, that's pure vinegar, isn't it? You're adding X milliliters, and Y is only 8%. This 0.08 is 8%. And the final result was 31%, wasn't it? How much do you have in the final amount? 60 milliliters. My whole job is to find out the amount that I used of that and the amount that I used of that. Let me rewrite them to look a little better. X plus Y equals 60, that was okay. Then we have X plus 0.08 y. Multiply that, I think it comes out to 18.60. What I'm going to do to solve this system of equations is this. I'm going to multiply the second one by -1. Do you understand why? First one, let me go and rewrite it. Second one, now that I've multiplied by -1, I'm hoping it becomes obvious now. Running out of space. The reason for multiplying the second one by negative is, what if I add them together now? What happens to those x's? They cancel and you get 0.92y equals 41.40. By 0.92. And if you would have done this, if you're doing it on your calculator and you saw this, your calculator all of a sudden showed you this. Would you have high confidence that you did it right? That's what happens when you do that division, is you get nice good line. I know. I was already making my way over. Now, where is the absolute easiest place to figure out the amount of vinegar that was used? What's the absolute easiest way to get your X value down?
Sure. 60 minus y.
You got, that's right, that's right. This equation couldn't be easier, could it? If X is 15, what's, I mean, Y is 15, what's X gonna be?
Y should be 40. That's the check. It's like, they know what.
Let's talk about that in a minute. Y is the amount of Italian dressing.
It's 41.4 divided to 45.
Oh, did I make, oh, I'm sorry. I was going based on memory. Okay, yeah. Thank you. I wouldn't have been involved before I seen that one. You get, this is really cool when you get to do that. All right, so Y is 45. Can you tell me what X is? 15. You got it. X equals 15. And you can get that from the first equation. I don't know. But X plus Y is 60. And from that, you get that the X is 15. So we finish it off. 15 milliliters. I think milliliters is a capital L. Of vinegar. And 45 milliliters Italian dressing. Now, I do want to address your question. Here's what I thought you were asking. You said one is 45 or one is 15. Let's go back to the original question for a second. I'm taking two mixtures, or two things that I'm mixing together, 100% and 8%. If my outcome is 31%, can you tell me which one I use more of? You use, no, the 31% is what, and look what you get in the end. You're taking this and this. I am literally taking vinegar and salad dressing and dumping them right into a can. Which did I use more of? That's what I'm saying.
That's how you dress.
How do you know that?
Because you had less of it, so you basically you're diluting it.
I know, that's right. You're always diluting it, but 31% is closer to salad dressing than it is to vinegar, isn't it? So you had to use more salad dressing, otherwise it'd been closer to 50%. Or whatever the actual mixture average of these two is, which is 54%. That would be it. I never thought that would probably, I'm surprised I've never had a student say something like that. That's a reason for why they didn't know a problem. Other questions on this? Yeah, for a matter of opinion, they wouldn't. Do we want to do the third one? I think the plan A and plan B, people did really well on that one. Except I found it is easier with decimals if you did it that way. Other questions?
We kind of go over 7 because I still keep messing up the whole above and the below.
Let's be number 7. And we are doing. We have y is greater than negative 3x minus 10. And then y less than 3x plus 2. Get our Okay, let's start first with the first line. Tell me how to graph the first one. I'll grab my thick 3x minus 10. Tell me how to do it. Down to 10, 1. So you were at the bottom of the page. Now where do you go? You probably couldn't go down 3, could you? That's correct. You'll have to reverse yourself. You don't have a choice. Now, remember, I set out paper and stuff like that when you take your exams. There'll be graph paper set out too. If you wanted graph paper for your scratch, you're allowed to have that. And so that might help. If you get a graph that you're happy with, then you can go and copy it onto your test. Yeah, I don't require exact answers for these kind of things. I just need to know the area that was. Well, I wanted to go down 3 and to the right one, but I ran out of graph. So if you can't do that, what do you have to do? You have to reverse yourself. And that's what I did. Now, don't yell at me when this line comes out solid because I'm not done with it yet. It's harder for me to do this than it is for you. All right, I have to change it to ink or drawing. All right, and then how do I shade this greater than? How do I shade above or below that line? Yeah, above, because y is, you've got to think of the y values. Are these y values greater than, or talking about up? Remember, you have to convert. On the real number line, to the left are smaller numbers and to the right are bigger numbers. Well, we just take that same line and turn it vertically. So the lower numbers are down here and the bigger numbers are up there. So you've got to be able to do those things. Let me go ahead and shade above it. And I usually just did this. I sort of gave you an indication I think would be smart. So on the above, what I'm going to do for this one is I go horizontal. This is the side of it I want. You'll admit these are much easier to do in whole, aren't they? All right, let's get the other one in. Y is less than 3x plus 2. So let me get my initial point started. Now I'm working on this guy. Tell me how to start this one. Y equals 3x plus 2. So I'll start at the origin and go up 2. I'll put my dot there. How should I go from here? To the right one, that's right. Mm-hmm. And once again, you can see where they intersect, can't you? Right on that particular spot. I believe that's enough. Skinnier line. Ah. Yeah. You see it jumped off that thing on me. All right. And then what are we doing, above or below on this one? Below. That means it's gonna be this. Oh, I'm wrong. I thought this was the spot. Nope, I did the shading wrong. So let's get the shading in. I'll have to obviously fix the test, but. I shaded the wrong one. So from this one. Shading, what should I do first? Should probably change it to a dotted line. Both of them are dashed in this problem. Now let me erase pieces of it. All right, this one, then you said below? Go from the line. Now you've got to try to concentrate on this line itself. It's hard to do when you've got other graph there. But I'm talking about this area. So I'm only going up to the line and going below. That would include all this area out here too. All this is below that line, isn't it? So can you see the area that is involved? Yeah, I made a mistake. I got to fix my answers and some tests probably. So if you get the right spot, if you have the wrong spot, it probably won't tell me if you got credit for it. But the outline, in case you don't see what we're talking about, you know what I could do? I never even thought about this. Let me have this. What will it do? I can almost get it in there just right. How wide you can make it. What's that? But it's all this over here. Let me have this back. And I never thought about using the line to define my region. That up against there. I'm not sure I can make it any thicker, but at least it will keep me away from the edges because I have a hard time keeping in the lines. But you guys understand it's all this area out here? So if your test, if I took off points because you had the correct one and I made a mistake, I'll fix it. When I did the answers, I thought it was in this little V shape, but it's not. All right. Other questions? All right. Then for those of you that you can give me your test after class or during the break or whatever if I had to fix it. Let me go. The other test I'll just do because I have them. We only have 3 minutes till the break, but let me at least write down this stuff then so I don't have to do it after the break. That was what one? What was number 5? Oh, yeah. Oh, yeah. Nobody did that. Almost nobody did that. All right. Let's see. So, yeah, good. That's a good question. I like it. I would like you, first of all, this is probably not something that you knew going into this. But did you notice that the two are defined symmetrically? What that means are the same. So it's up to you. I personally, at the very sight of fractions, I might do something like this. And could you tell me what I just did there? Why did I do 3? What would make me choose 3? 1/3, right? Similarly, I can do identical stuff over here. I never actually, what I probably would do at this stage, so I'm going to treat, I'm going to act like that. Given this. Okay. I really don't care how you do this. It's not complicated, but it's also sort of a pain. See what I did there? So all I did was add y, but I also subtracted 3x. What do you think I'm going to do with that y? Plug it into the other equation. If you've had the unfortune of plugging it into the same equation, you'll end up getting something like 0 = 0 or some other useless thing. It's not wrong, but it won't help you solve the problem. So now I'm going to replace that y. So the 3y becomes 3 plus 12. Negative x plus all that. Hopefully you can see that I will distribute the 3 on the left side. I put negative 9x plus 36. Solve that equation, which I wouldn't. Well, I mean, you can. I'll tell you, I just do whatever you. The point is, you can do it. I want you to make. It's not a slicker way. All right, so with doing that, I have negative 9x. It's negative x minus 20. Now, not yet, you've got x by itself, yes. All the x's on one side of the equal. I'm going to add x to both sides. That's all. I'll tell you why I wasn't going to do exactly what you said. You'll see in just a second. Although it probably I spend more time. I was just wanting to avoid the negative in parentheses. But you don't have to do it. Finish this, you can divide by negative 8. And you end up with x is equal to 3. I told you because of the symmetric nature of the problem, y is also going to end up being equal to 3. I don't know. I'll show you. We solve for y over. So then I would put it in for x. end up with -9 as well. So you would. It's not the only way you could have done it. You could have done substitution right off the bat. Did you know that? Well, that's the way, I love the symmetry. Could have, right initially, this one, you could have taken this here, plugged it into that X. You would have just had fractions to deal with. 1/9 would appear, 1/3 would appear. It'd be annoying, but it would still be doable. All right, so now I went over. Once you take 10 minutes there and come back about 3 after, I'm gonna put these answers up in Blackboard. Okay. Anybody tell me this is, we're switching now, completely switching what we're doing. And now we're gonna concentrate on exponents. It may seem easy at first, but wait till you see what we do with them. Anyways, does anybody know what the answer or what that thing, the value of that thing is? It's equal to 2 times itself. You got a total of 3 2s, right?
So 2 times 2 times 2? Okay.
What's that equal? You wouldn't believe how many people say 6.
8.
So we're good there. How about this one? 4 times
16.
4 to the 3rd power. 4 times 4 times 4, yeah. With your calculators, nothing is impossible. At least not of these problems. I think you'll find that is 64. Yes, in fact, when I write this, we're start looking at stuff. Everything that we look at is now going to be of this format. We're going to have some number, let's call it A, and be raised to some sort of an exponent. Everything's going to be dealing with this. So the B, I probably should have, may seem weird to you, why I'm going to make the change, or I'm going to change. Let's see how this works. B to the P power, that's right. So the P is called the power or the exponent. Either one of those, I don't care. I didn't use the letter E because we reserved that for something else in time. What do you think they call this number B that's in the bottom? No, it's not a denominator. Base. I chose my letters to match the thing. B to the P. What's that?
Not British Petroleum.
Yeah, that's right. So I'm trying to make it as easy as possible because, well, let me just show you where some of the first problems come in at. And we'll see what kind of preconceived notions that you have are. Remember, we deal with negative numbers as well. Can you tell me what this is equal to? 16? Did you say 16? You type it in your calculator exactly the way it looks like that? Why not? Type it in identical to what you see on screen.
So I was right.
Ugh. Hold on a second here. Let me pop over to, I don't need this thing over here. Have you guys ever seen this thing? I'm gonna go to a website. You guys ever heard of Geogebra? It's a monstrously powerful graphing calculator system. It's far beyond anything you can buy. Anyways, you can do tables or whatever you want over here. We have -4 to the 2nd power. That is identical to what you typed. Is that what you typed? And is your thing that you do it all in one line like that? Or do you type -4 and then you hit the X squared button?
So it's a -4. It's squared.
Okay, so you're not able to, all right, it's, yours is doing, yours is not like, the calculators where you would write it. Yeah, most of the people who type it into their calculators here, depending on the calculator, they have to do this. You unfortunately are in a worse group because your calculator is passively lying to you. But when you do this on your calculator, you type that and then you type this. What it automatically does is it puts it in parentheses and doesn't tell you. So, how do we deal with this? Is this positive 16 or negative 16? I'm here to tell you that it is negative 16. What's that? Well, let me, this, you, if this was a minus sign, which I've said a few times, you should probably think of the negative as minus. Just call one negative one, it's easier to do that. Minus one, it's easier to do that. With that in mind, if that was a minus in front of it, what would you do first? Would you do the minus or would you do the exponent? You do a minus over an exponent. No. The order of operations we learned at the beginning of class. You do the exponent first. And so you would write this -16 because you did the exponent first. What is the only thing that overwhelms or is more powerful than an exponent? Parentheses. Your calculator, whether you like it or not, is evaluating it this way. I should probably look at it for you.
Is it, so wait, is it 16 or -16?
That's the whole point. Because, yeah, you have, unfortunately, you don't have one that shows the displays.
So I type that.
So, no, you would do 4. Oh, okay, then perfect. 4, you would do the exponent first, correct? You would do the exponent first. Your calculator is requiring you to know the order of operation.
So would it be smart for me to do?
No, that would be positive 16 because those negatives will cancel out. So the whole point of this exercise is to try to get you guys to know how to deal with this. So let me write these up here. Now, I will admit, the beast that I'm trying to conquer by teaching this is a big one, and it usually wins. Because what happens is students try to memorize it without the feeling of why it's true. And the fact is, they look different, don't they? They physically look different, so they should be different numbers. Not always, but they should be. And so you have to remember, what is the negative, what these parentheses do? You do parentheses first, right? Those are the only things that win over exponents, isn't that true? So when I have the negative in here, I do these in 2 different ways. To do that one, according to the rules of arithmetic, you would do this. You would multiply 4 times 4 before you can do a minus. This one looks like -4 times -4. And what happens to those negatives? No, it shouldn't. This says whatever has the 2 under it, you take twice, right? Is that negative under the 2? So what do? I don't know what students do to memorize this. But I've tried to say, like, according to the order of operations, take this out. I'll give you everything I got. Would you agree that this equals that? That's true. Now, which would you do? Would you do the negative? Would you do multiplication or the exponent first? summation over an exponent.
And is. So,
That means you have to leave that -1 dot alone, don't you? What do you end up getting? I don't know how much more to do because this is a struggle every time. I can't stand teaching this particular topic. This is not exponents. This particular thing. It is annoying to no end. And you can see that exponents are not going to be the joy that we thought they were when I first wrote up 2 to the 3rd power. Are they? What'd you say? Oh, sorry. This is nice.
which one actually supposed to be right? Negative 16 is.
That is correct.
Okay.
This one over here is 60. Oh, I am over here.
But if it's in parentheses, it's positive. So if it's over something, it's positive.
Oh, here, you want to have one? Try this one. I know you
It's
can.
double that.
But that would be cool. I can't wait to see.
So in parentheses first, that's parentheses, so it'd be -1.
No, all right, so let me move this out. You're gonna do the, what's -4 squared?
Square is 16, and this parentheses over something.
So,
-1 times 16.
oh, you're done. That's it.
Done.
No, you're not, I totally think I was like, don't let that thing. Texas Instruments has a whole group of people devoted to trying to get students to fail. I don't know if you if that about the equal plot.
One more calculators.
Yeah, more calculators. You know, this whole time we think about, you know, the war going on in Ukraine, like nuclear weapon. No, Texas Instruments is the one to be feared. All right, so I don't know if I've gotten past that. Now I can actually proceed with actually doing the stuff because that painful thing has to be dealt with. All right, so now let me deal with something else. If I ask you to do 2 to the 4th.
It's gonna have parentheses.
Yeah, of course. No, you don't, right, correct. Sixteen somehow got 48. But this is equal 2 to the 3rd is equal to 8. Is equal to 16. Times 16 is 100. Yours what allows you at least to see. His doesn't allow you to see the light. His is the old fashioned kind of punch number. Yeah. So did you do 2 to the 3rd? Times. You have to do the equals 4, because if you don't and you put a times, it'll think you're multiplying that exponent by. Two. So if you don't type equals after you type the 3rd, it may attach this to that exponent. if you're gonna take more math, that's not seriously. Well, yeah, not, I mean, this one that everybody else is using is less than $10 at all. Don't buy it from the bookstore if you can help it. They really, oh, let's see, yeah, yeah. Nowadays, you can almost walk down the street and find a calculator. You know, they give them to kids as they. All right, so anyways, this is not what I care about. The 128 is not what I care about. What I do care about is this. That 2 to the third is 2 times 2 times 2, correct? Then I have 2 to the fourth. How many 2s? How many total 2s do you see now? Now on your calculator, do 2 to the 7th power. See if you don't get the same answer. So, well, the thing about it is if you just choose a calculator without any understanding what it spits out, you have to know more math to understand more of it. But I'm not, what I'm more interested in is the fact is that we had 2 to the third and 2 to the fourth equal a total of 2 to the 7th. So what I'm telling you is it's 2 to the third times 2 to the fourth equals 2 raised to the 3 plus 4. I added those exponents together. That's what I'm getting at. This is, I think it's the power rule. I forget the name of it. It is, let's call it a product rule.
So, Professor, does it only work if you have the same base?
That's correct. That's correct. Because then I wouldn't have 7 of the same thing, would I? Have all these 2s. I need all these 2s to be the same. Otherwise, I don't have one base for 2 state.
Okay, gotcha.
To apply the most basic version of exponents to it. You can't, there's ways to do it, but it's not in this class. Those are required law work. Yeah, you could, but unfortunately, if you wanted to replace it with what it's equal to, it will look much worse. So that. So the rule that I'm trying to get here is, if I have a number, let's call it b, and I raise it to an exponent, and I take the same base and raise it to another exponent, then the rule that I'm using is that I can add the exponents together. This is called the product. I'm going to pull a few examples out. All I want you to do is combine things and collect. 12 raised to 4. 12. 12. 7. I'd like you to rewrite that as 12 to exponent, to a single exponent. But what do you have? What's going to be? You have 4. 4 plus what? What about that one? Yeah, we kind of, we do stuff like, I ain't gonna give you tricky things. But then what do you end up getting?
35.
No, I don't care about the number, just give me the exponent.
Out of 7.
Many times that's good enough. Because think about if you were, just for example, let me tell you, a lot of times when you read newspapers or when you're submitting a report for a real job, let's say something along these lines. Do you think that this guy is going to read 35 million all the time? It's going to be covering the page for that big thing. So you also have to determine what, I mean, 12 and 7 is a big number. We can all agree on that.
Just want to check that says that.
But you can't, well, it's the idea, actually, yeah. If you want, if you do this, then you got the same as when you do this. Exactly, good idea. And how about this one then? So you're not actually required to tell me what the actual number equals. I just want to rewrite it as an exponentially form. So here I have -3 fifth power times -3 times -3 sixth power. So all I care about is this -3 to what? To the 12. To the 12. Because if you take 5 plus 1 plus 6, you get 12. Now, a lot of times these things say like simplify. So we'll just say that term. But this word simplify means literally different things every time in different sections. So what they want you to do is to write this as a single exponential expression instead of a product like I had. So now we're going to drop numbers, a lot of numbers, and we're going to concentrate on the algebra part of this. What did you say? X to the 7th because you add the 2 exponents. Exactly right. Those are the kind of things they're expecting in this section. How about something like this? X to the 6th power times 10 to the 5th times n squared. Now what is it going to be? It's going to be n to what power? All those numbers are up there in the exponent. N to the 13th power. Frank? We have different things. Stuff. Eventually, I was not waiting a second. Let's see. It's time to. So what should you get? Or 10? The 10 cannot mix with the C. We don't know what it is.
Oh, we can't. Anything to the 11?
Until I know what C is, I can't really multiply 10 to it. So would you say C to the 11? So yeah, same deal, they have to be multiplicatively, what do you call that? Like terms.
I thought it was Tennessee times.
It doesn't matter, it really doesn't matter what you're, oh, you mean Tennessee is the like, that was the letter?
That was the letter, like it was Tennessee.
Oh, no, anytime you see Tennessee, you know it's 10 times.
That would have been 18, 19, 20.
So anytime I see something like this, you know it's supposed to be 5 times that, right?
Yeah.
Same deal.
That's okay.
Now you'll see, in this problem, next one, you'll probably figure out, oh, yeah. I have in parentheses, 8h to the 5th. Another parentheses, negative 5h squared. As the problems get more algebraic, the calculators are less these, aren't they?
So, yes, I got 3.
You said, what'd you get?
38 to the 7.
So you took 8 minus 5. And this is times in here, right? That's what it means when you have the parentheses.
So, negative 40
There you go.
h to the 7.
That's right, negative 40 h to the 7. How do you get to that? I'll explain how all of them happen. But the beauty for you is you can just, the numbers and h's are not mixable. You understand?
Yeah.
I can only put the numbers together. So what I can do is rewrite this problem as 8 times negative 5 times h to the 5th times h squared. I don't care that you know that so much because what I used was the combination of our commutative properties and the associative properties. But what's important is I put the numbers together and I get negative 40. And I put the letters together to use my product. As long as you got a handle on that, this won't be a big deal. But if your mind is going to make you do weird things like you're talking about, and students do that, it could be horrible. Are you ready for the powerful one? Let's see what kind of what you got. No holds barred. 12c to the 3rd power. So that's 14 over 15. Let's see now, right there. Take a few minutes on that. I'm going to sign homework while you do. Alex. Ooh, honey. Anybody think they got it yet? And give me, I didn't do it, but go ahead and, there could be, because let me see. We've got in the denominator, I would have 105. Do I have 105 that takes up the numerator? I have 65. Well, let's see. What do you got? We have two problems. First, what's the other one? What difference does it make? Let's see which one you use. So when you did the numbers, did you do this? 12 over 1 times 14 over 15 times 5, 7. C to the third. C squared. Did you do all this?
No. It's a whole C plus C3 plus 2.
That's fine. But basically, this is the idea, right? Now I can group my C's together, and what's going to be the exponent for the C? Yeah. Plus 2 plus 6 is 11, right? For the fraction part of it, I probably would have done a lot of canceling. Like for this, you see this one? How can you possibly pass that up?
Yeah.
We do this, we can 1, third. But there's even more, you're not even done yet. Oh. 2. 12 will wipe out that 3 once. So that 3 will go into 12 4 times. And what do we have then left of the numbers? 8 C to the right now, as if that wasn't any fun, and all we do is we just keep pushing and pushing. 2.1b, it's just more exponent rules. And let me see if I could, well, let's see if you can make. Are they gonna do that yet? No, they're not. All right, so we'll just do some examples. Now, you've ever, if growing up, you were part of a loving household. You may have had an argument with your mom or father, something like this. I love you more. No, I love you more. Have you heard of this argument? Yeah. Perfectly winnable argument. So what does he try to do? Eventually someone says, I love you infinity. The other one says, I love you infinity plus 1. So they're topping whatever you did. We're going to top what I did last time. Suppose I give you this to do. 2 raised to the 3rd power. But then I take that and raise the whole thing 4th power. A parentheses inside of the exponent now. So this is a combo problem. How do you handle this? What part of it would you do first? You would, no, you wouldn't. No. What's the part you have to do first? Inside the parentheses, there's actually something to do, isn't there? 2 to the 3rd equals what? 8. So this guy can rewrite as 8 to the 4th power. So that equals 8 to the 3rd, 4th. You say it was 4,097. What if instead I wanted to write it in terms of 2? So let me show you something here. Tell me if you agree with what I write. Next. Right, we have. Since 2 to the third was raised to fourth power, it's itself 4 times, right? Now each of those 2 to the thirds. If you have that, don't you have this equal to 2 to the 3 plus 3 plus 3 plus 3 is 12. Right, our last row, we add the exponents up, it equals 12, right? This is also equal to 2 to the 3 times 4. Times 4. In fact, there were 4 things up there, weren't there? So, let me read this. This is called power. If I take and have a number and raise it to an exponent, then I raise it to another exponent. That's a to the n times n. So then when I have to do the last one, you can have the calculator help me with this one. Suppose I do 5 squared to the third. First, write it as 5 to a power, but then let your calculator tell you what it equals. So what would be 5 to what power?
So it's 5 to the second power.
Well, I just put the product. I want to make use of this. What did you say?
It's 5 to the sixth.
5 to the 6th power. That's what I'm looking for. But if you do 5 to the 6th power, what do you get? I didn't hear it. What was it?
50,600.
Most of the time, I don't even care about the final answer. I'm more interested in this because it tells me understand the power rule. You were asking about different bases. What do you think you do with something like this? That's right. They're different bases, aren't they? You definitely cannot combine them. You're correct. You could, now this whole section though is trying to show us how to break out the parentheses if we have to. But we can't. You can't. If you want to, you get the same answer as I do. That's the factor in computation. So you can do 8 times 9 and then do 72 to the 4th. That is correct. But if I want to make use of our exponent rules, the rule that I want to show you next is that it equals this. So I'm going to have 2 to the third. You're allowed to break it up like this. Which I think is what you were just saying. I can tear it apart like that. Now, what does the product rule tell me that I can do? These. Starting with the 2, what does the product rule tell me?
It's 2 to the. It's 3 plus 3.
So this will be 2 to what power? 4. This one. this would be 2 to the 12 times 3 to the 8. This rule has a name, I'll find it out in a second, but if you take a number times another, raise it to a single power, you are permitted to break this up. Yeah. Let me give you the name of it. It's something with a power in it, probably. They call, oh, nice. Power rule for a product. All right, so in your book, on page 94, if you're looking, you have all the product and power rules. Well, you know what, let me just grab them. Since I got a minute left, let's throw them up and then you won't need to look for them. They have them all in one spot. That's page 94. I'll throw them up on this and then you can have them for your use. Let me finish this assignment. Oh, what am I doing? I was on page 94. That's where we're at. They have all of them in one spot, so I'm going to put it up in here. And then you can use this for whatever it is you want to use it for, but it's helpful. I think they have all of them in one spot. Do you think? So on class today, we're showing you that today's notes have this very important collection of rules on them.
We do ask for specific rules.
No, but I will give you problems and expect you to know how to use the rules. But I know I don't ask for any definitions or anything like that. All right, if I screwed up your test, please give it back to me so I can correct what I did wrong on it. And then that's all I have for today. Did I mess yours up?
Yeah, the last one.
All right. Into the recording. Stop.